Let us now focus on the variance of a random variable. So let us start with this. The example we have here is here. We are going to see how we prove it. The variance of a probability distribution associated with the random variable x is given by var of x. We say var of x minus the mu, where mu is the mean of that random variable. And then when you simplify this, you get to this. You are going to see how it comes about that. Then the properties, let a and b be constants. Var of the constant is 0. If a and b are constants, var of a is 0 and var of b is 0. Then var of a, x, is equal to a squared var of x. Then var of a negative a, x, the same as you square it, then var of x. Then var of x plus b, the same as var of x, then plus var of b. And we said var of the constant is 0, and var of this coefficient, it comes and squares there, as simple as that, which will be that. Let us see this example here. A random variable x with mean this is given by this. This is how they are giving our PDF. This means that this shows that it's a discrete. Why? For each value of x, it has a specific probability. Then this, and then anything which is not 0, 1, 2, and 3, it has 0 probability with this PDF. That's what it means. To show that the variance of x is var of x given by this which we have seen here. So now solution there, we start with this. We have seen that our val of x is the same as e x minus mu, the whole squared. So can we expand this bracket? We expand this, we have x squared minus 2 mu x, then plus mu squared, expanding this. Then after, we know that mean has a property, this expression has a property of going through all this. So this would be e of x squared, then minus e of 2 mu x, then plus e of mu squared. So this will be e of x squared. Then you see that these are constants. This is the variable, so it's the same as 2 mu e of x. Then plus this is the constant, which will be mu squared. And we say our e of x from the equation is mu. This will be e of x squared minus 2 mu times mu from here, from the equation, then plus mu squared. This will give us e of x squared minus 2 mu squared plus mu squared, which will give us e of x squared, then minus mu squared. But our mu squared is this expectation, which will be now e of x squared minus e of x, now the whole of it squared, because our mean from the question was given there. Not that our mean is this. So, and the proof is done. So, that's why it's given by this. Find the value of k, and hence find value of x. We have seen value of x, and then x squared, and then the expectation. So, we can come. So, from here, our PDF, so this is the PDF. So, we say, when x is 0, our PDF, so our p of x equal to 0 is going to be, when I put here 0, I'll be having to k. When x is 1, I'll be having, when I put here 1, this one, 2 minus 1 will be 1 times this, which will be k. When x is 2, probability of 2 will be, when I put here 2, it will be at 0. And then they are telling me, when x is 3, this is the probability. Now this means, when x is 3, this is its own probability. This will be p into x equaling 3, equaling to, when I put here 3, so I'll be having k into 3 minus 2, which will be a k. So that's it. So to get the value of k, I know that when I sum all these ones, we shall get a 1. So when I sum all these individual probabilities, I should get a 1. So meaning when I add 2k plus k plus 0 plus k, I'll get 1. These are giving me 4k equaling to 1, implying my k is a quarter. And if you have it as a quarter, you can able see this one is going to be 2 over 4. This will be a quarter. This will be also a quarter when you come and substitute there. Now it means that we need to get this, we need a square, also we need this. So we come and we draw our simple table like we did in the last question. We draw a simple table there, which we are going to use to calculate the mean. Or you can do it in one step, but the table is greater, so we don't do a lot of mistakes. So we have 0, we have a 1, we have a 2, and we have also a 3. So these are our probabilities. These are our values of x. So they are ending there. Then I come and also input my probability. Okay, I also need x squared. So if I put probability, I also need x squared. For me, I need x squared. X squared will be 0, 1, 4, then 9. Then I cross this. Then I need also these probabilities of these variables here. The probability of 0 from here, 0 was 2 over 4. Don't reduce it because we are going to use it further. When x is 1, probability was 1 over 4. When x is 0, and when x is 2, the probability was 0. When x is 3, the probability was k, which is 1 over 4. Now we start with x times this. We need now x. Probability of x equaling to x. What happens when I get this? I need this now times this. This times this will be 0. This times this, I get a quarter. This times this, I get 0. Then this times this, I get 3 over 4. And so from here, when I sum now all these probabilities, I'll get with more prime than the corresponding value of x. This will be 1, this will be 3, and this will be a 1 from me there. The expectation is 1 from there. Now I also need x squared times the probability of x equaling to x. I also need that. So now these are now squared. So this times this times the probability, I get 0. Then this times this, I get a quarter. Then this, I'm doing with x squared times the probability. So this times the probability, I get 0. Then this times this, I get 9 over 4. So the LCM is the same. So when I sum now x squared equaling to x, I get this will be 10 over 4. Then we come and substitute into our formula. So we need the value of x. Our value of x is the same as e of x squared, then minus the expectation, the whole square. And from here, we are seeing that our e of x squared is the same as the sum of x squared times the probabilities, which we have got as 10 over 4. Then our e of x, which is the same as the sum of x, probability of x, and you are seeing this is a 1. So meaning, and now if we substitute here, our value of x is going to be now 10 over 4 minus now 1 squared, and this will give us, and of course multiply there, we shall get 6 over 4, which you can reduce to 1.5, and that becomes our answer. So that's how you handle that, members. I wish you well. Unless there is a question, you can leave it for me there. So that's how you handle that. That's how you prove the value. That's how you get the value. See you.